Welcome to our talk. I had to change the title a little bit from what you saw. I hope this doesn't upset you too much. This is about 2010, it said in the brochure, but I got enough permission to talk about vNext. So I hope 2010 is only a subset of the whole talk. If you're upset by that, I can always just talk about 2010, but it's up to you. If you don't like my jokes, I have canned laughter. and during the video streaming, it actually comes through that way. So it doesn't really matter if you like my jokes or not. I look good anyway. So my name is Terry Leeper. I work in Visual C++. This is Rong Lu, who works with me in Visual C++. And we're talking about some of the ALM features for C++. So how many of you actually use some of the ALM features that we already have in 2010? So what do you use? Not in C++, you don't. Okay. Kate, what do you use? Okay. You could use source control for C++. You know, it's an interesting thing. Now, he's referring to the CLI IntelliSense that we took away in 2010. And every time I tell people it's back, they give me great applause. And I'm thinking, what kind of behavior are you teaching me? If I take something away from you, and they'll give it back and you applause, what is the behavior you're driving to me? It's like, I'll take away a lot of features and put them back if you'll give me lots of applause. So. Yes, so thank you. I wouldn't have guessed that. No, actually, that's actually good. We did scale out the 2010 architecture to handle IntelliSense much better. Unfortunately, we left out the CLI part when we were doing the infrastructure, and so there were a lot of people who were quite upset with us about that. The good news is we found out a lot of people were using CLI that we didn't know. So that was actually good learning for us. So that was really pretty cool. So let's talk about our agenda. Talk about some of the ALM features for native code, and this is application lifecycle management. Are all of you developers? Are you kind of a mix, or anybody not a developer? What do you do? Okay.
Not really like full time.
Okay. As needed. Okay. So we're going to talk about some of the 2010 ones that are already in the product. Then we're going to talk about Visual Studio vNext, some of the new features for native, and then we're going to demo quite a few of the new C++ features, and that's going to be the bulk of the presentation is the demos, which I hope you like. And then we'll try to leave some time for Q&A at the end.
Can you just frame one thing for me? Like, you talked somewhat about the other languages. Organization within Microsoft, C++ is an entirely different division from the managed code languages like F# and C#, that seem to all work together, and they co-develop the products, or they're kind of on their own island.
So the question is how is our organization layered for C++? We're all in the same division. The C++ team is not in the same team as the managed languages are in the same team, which is why a lot of the language features work together. But a lot of the things that are kind of neutral, like the shell, the debuggers, they're separate teams. So this is my one marketing slide. There were 15 of these marketing slides, and I put them through the C++ compiler, and I ended up with one. If you give me a hard time, I will compile OD for debug mode, and you get all 15 back. So be careful what you ask for here. So Visual 2010, we divide things into kind of different SKUs: the Ultimate SKU, Premium SKU, and Professional SKU. We have another SKU for test professionals. I don't think this is all really that new to you. We have a Team Foundation server who houses all the things. It's basically made for teams to work together. So the developers, different developers, testers, project managers, build labs, all those kind of work together as one team. So let's talk about 2010. Now, one of the hard things for the C++ guys is is that when you go see a demo of a new feature for Visual Studio Team System, you'll often say, that was a pretty cool feature. You go home and try it, and guess what? It doesn't work for native. And then you get to the point where you wonder, does anything work for native? Right? So then actually there's some cool features that you're not using because you don't think anything works for native. So actually you go to the, like you personally, but a lot of guys have gone to the far extreme. So I want to talk a little bit about what's in 2010, what works for native and what doesn't work for native, so that way we can start from a certain point of view. So that way we can all talk to the same language. In the premium SKU, lots of things do work. Code coverage tools work. Static analysis, being able to look at the different warnings and things through your code, and it looks at the different kinds of problems you might find in your code. Profiling works, which is probably the most popular feature for C++ developers, and concurrency profiling. Now, there are a few things in the premium SKU that don't work. So code metrics does not work. Coded UI partially works. It works for some MFC applications, but that's all. And test data collection doesn't work. So most of it works. How many of you are using some of these now? How many of you didn't think these worked? Okay, so good learning today. All right, but these actually work for C++ in 2010. And the ultimate SKU, two things kind of work pretty well. Load testing, which is kind of stress testing, we call it at Microsoft, where you're putting a lot of different, simulating a lot of loads on a system. And lab management. So this all works. Anybody use these two? Did anybody know these worked for C++? No, kind of? Okay. So these work. Now, what doesn't work in Ultimate? So the biggest gap in Ultimate is really the architect tools. Discovery, the UML diagrams, the layer diagrams, dependency information. These things don't work for C++ in 2010. That's probably the biggest gap. IntelliTrace is probably the other one that people would like to have. TFS, virtually everything works for C++. Source control, it's very neutral, works just fine. Team build, so being able to schedule your builds, being able to do rolling builds, branch strategies, those kinds of things work very well for C++. And we use those internally as well. Any questions so far? Yes?
I guess just, do you include testing in application lifecycle management?
We do.
All right, I have a question on maybe more appropriately, but I know the code contracts are in the mix somewhere. Is that a research feature? How's that fit?
Code, say that again?
Code contracts.
So I'm not sure what that exactly is.
Oh, okay, all right. It must be research, because I saw some of the materials out.
It could be. So that concludes my entire section on 2010. So you can see my talk changed quite a bit. I want to talk a little bit about what's already in there. So many of you probably are using profiling too. If you're writing in C++, profiling is a very, very key feature for you. This is the linear profiler where you can look at the CPU usage over time, filter by selection. You can look at hot paths, cold paths in your code. Very useful. Virtually all my C++ customers use that. Load testing, we talked about that a little bit. Series of web tests or unit tests to simulate multiple users over a period of time. Concurrent, how many of you do concurrent programming or parallel programming? Do you use this? This is pretty cool stuff. So the concurrency visualizer is really the concurrency profiler. You can look at a number of cores in your machine. You can see it's color-coded so that you can see what your processes are doing versus the idle time versus other processes in the system. So you get a really good indication of how much CPU usage you're getting out of each core. We have a thread visualizer, which is really pretty cool. You can look at each thread and analyze that and see where it's paging, where you're getting I/O, where you're synchronizing, so you can have a really good graph over time of what each thread is doing in your application. This is very useful. Even if you're not doing multi-core programming, vast majority of C++ guys do multi-threaded, so this is a pretty cool feature. You can look at the different cores on your machine. You can look at the different, we actually color code the threads, so you can see what's happening, which threads on which core, and visualize that over time. This is very, very useful in looking at bottlenecks and synchronization issues. Okay, that was it. Now we're down to vNext. I'm trying really hard to call it vNext because they just told me to start using that today. So several 2010 features have been updated. So we're going to show a couple of these today. So the static analysis tools have been greatly enhanced, especially around the UI. And Rong is going to show that today. The code coverage tools have also been greatly enhanced. So they give you code coverage in your work. You think about it. We're adding the architect tools to C++. We're going to show that today. And some things are very, very unique to C++. So if I don't get an ooh and ah at a couple of these, I'm going to OD that marketing slide set. Unit test. We have created a unit test framework for C++. It's based on an internal implementation. So if you've used CPP unit or Win unit or some other things that we've had semi-externally, you might be able to map those or write adapters for those or just use ours. It runs natively. So the unit test framework itself runs natively. We do use a managed test manager. So the one that does the distribution is managed code. But you're using Visual Studio, and that's also managed code, so it should be a big deal. And then what you saw yesterday, how many of you saw Jason's keynote? How many of you went to Cameron's ALM? Okay, so they showed a lot of stuff. I'm not going to reiterate all of those. Virtually everything that they showed works in C++, which is a big change in direction. A couple of things that we don't have. We don't have the code cloning, so we're still working on that. And he showed IntelliTrace again, which we still don't have that. But all the other stuff around sprints, code reviews, backlog management, all those things all work in C++. So you'll be able to use those right away. They're very useful tools. And how many of you use an agile type of development environment? That's not very many. So pure waterfall kind of organizations. That works too. Okay? So great news for, I remember I was in how many of you went to Diego's session last night? I remember I saw several of you. So there were some open questions around, fine, you're having a renaissance in C++ at Microsoft. Show me features. This is the first disclosure of new features for C++. This won't be the last. Right? There'll be a whole series of these coming forward. So there's been a lot of progress in vNext. Our native investments in the whole company have increased significantly. So I think you asked, when did you start this? So it was about 2 years ago. But it takes a long time to get all the stuff, machinery running to get products out the door. And now we see many existing ALM features are now support native, and you get to see those today.
Right, and the thing is, too, if some executive just states that yeah, there's a direction that C++ is going to be a full citizen, it's going to match everyone eventually, customers will be patient and just catch up.
Well, that's what we hope.
A lot of people are waiting for that.
I appreciate that. So great news for the C+ developer community, I believe, going forward. So, and now we're going to do some demos, and I'm going to give it to Rong, who works on my team. And she's a terrific presenter, so she'll be going through some of these new features. I'll leave it to Rong.
All right. All right, let's start with static analysis feature. As Terry mentioned, this is actually in 2010 that we shipped. How many of you have used this feature before? VS? One? Just one? And two? C# side. OK. Anyone of you are using static analysis, maybe not VS, some other tools? Anyone? No? OK. I'll show you the VS version of that. So this is a very early build of vNext, even pre-beta. And I just took it from our daily build machine. So you understand if anything happens. So let's say, start with this application. So let's say I join a new team, and my boss gave me this existing application and say, you play with it and see how it works and if anything we can improve. So I will just start with by running this application and see what it does. Well, I got a MFC application, and let me try this. Open a folder. OK. So I open this folder, and it shows me all the pictures in that folder. And I can double-click on one of the pictures. I can do rotation. I can back and forth. That all works. Looks pretty good. I will just shut down this application. Whoa. That's something you don't want to see in the demo. But the good news is it's part of the demo. So we're apparently running into a runtime error. Now let's stop this and come back to the application and see how we can identify where the issue is. Now I don't even know where to start because I'm new to this application. I have no background knowledge at all. And now let's see what tools can we use to help us find this problem. So I want to introduce you this new UI on the right side, on the left side. That's the new code analysis tool window. So if you have used it before in the early version of VS, we basically show all the warnings it catches in the error list. It's a flat list. Now we got this new UI, which actually will give you a richer information area, and it's basically help you to easily manage all the warnings. All right. So all I need to do is go here and say Analyze. It gives me all the solution or all the projects in this solution, so I can pick one of them. So I'm going to start with Photo Browser and see if there's any issues there. I can click on that. So just to save some time. This is what you got when you click that. So basically, we got 3 warnings. Let me show you what those are. So pretty common errors you might run into. So initialize memory overrun and no pointing dereferencing. So I want to show you some of the features in the UI itself. So what's been changed? Remember this different projects in our solution? You can actually filter by your project and only see the warnings in that project. And you can also filter by the level of how serious issues are. Could be warnings and errors you can filter. And also on the top, we got this search bar. Looks like all the tools now got a search bar. So if I hover on that, oops, it didn't actually show. But you can actually search, either use the warning IDs, or the warning title, or the file name, or even the function name. So you can search using all those keywords. Well, let's try one. Let's say memory. Now it fills down only to one warning. And then can go back to the full list. All right. Now let's start looking at all the warnings one by one and see what's different. So if I click on this one, you will notice that actually it has got a lot more information than what we had before. Now this is what you are used to. So it's just a one-line description of what the error is. But underneath that, we add this line explanation. Actually shows you all the lines that are related to this warning. Actually, it's the logic we use behind the code analysis, how we get there, how we assume the code is running and which path and how we got to this error. So now if I click on one of these, it actually highlights. Let me make it larger. All right. So I click on this line, and it highlights in yellow and says, OK, this one is not initialized. I declare this variable, but not initialized. And then I click on the second line. It highlights this for loop and says this character buffer index is used, but may not be initialized yet. So it's like the relationship shows you how we get there. So for this one, it's pretty easy. I just need to fix it by initializing it. Let's move on to the second one. The same deal. So we can start with this. It says custom state is an array of 4 elements. And then I click on the second line, it actually says, oh, I'm making an invalid write to custom state 4, which means I'm writing to the 5th element of the array. That's where the runtime error happens. It's actually a write overrun. So I can fix it by either making this 5 or making this number smaller, whichever I want. All right, so these are the 2 warnings. Let's move on to the last one. This is more interesting because it actually has got more information in here. So I can explain this. It shows me all these line informations. Now let me start with here. This one says, entering this branch, and the logic, we're assuming PTR is a null. Now let's move on to the next one. And it says, entering this branch, and we're assuming B is true. So that's why we get to this line. So I move on to this line, and this says, okay, you are dereferencing PTR, but it may be null. So it shows you the logic and how we get there. So it might be easier for you to identify the issue. So you can do a few things about the error. So maybe it's a real bug you want to fix, like I did before. Maybe you want to fix it later. You can maybe log a bug or a task for that. Or sometimes you will say, okay, I know this error, but I'm fine with it. I'm just going to suppress this warning, right? So sometimes you will just write this line that says, disable this particular warning for this line. So in the past, you often have to do that manually, type in that. Now we got this feature actually integrated with within this window. So if I click on these actions, you will see that there are a couple of options you can do. You can copy the message, or you can create a work item right off this. Now I'm not connecting to TFS, but if you are connected, you can either create a bug or task or whatever you want. And the last one is also interesting that you can suppress this message right from here. So just within one click, let's say suppress this one in source. So actually adds this line. You don't have to do that manually. Right? So with all these fixes, it should, if I build again, it should, all these warnings should go away. But to save some time, I'm not going to do that anymore. Just trust me.
We know that none of you would write code like this.
Yeah.
This is somebody else's code that you're having to review, so we set that up nicely.
All right, so let's go back. Right, that's right. Yes.
So the question was, is the same information available during command line builds? And the answer is yes. You don't get the UI, obviously, but
right.
All the warnings and things are still the same.
So the UI is still in VNext, but the code analysis tools are already in 2010.
Well, let's put it this way. There are two parts in code analysis.
The question, yeah, repeat the question.
Oh, sorry. So the question is, the UI is new in VNext, but the static analysis tool is already in 2010. So let me put it this way. There are two parts contributing to code analysis feature that you see here. One is the UI part. The other one is the underlying engine part. We do have an engine in 2010. But in the VNext, we're actually, well, can I say replacing it or just enhancing engine? Well, a lot better. And also we got this new UI. So the new engine actually can output all this additional information and the new UI can understand. So all this line information, we don't have it before. So the old engine doesn't output all this information, but the new engine does. Yes. Sorry, how do I get back to you?
Is this new UI unified across the languages?
So the question is this new UI unified across all languages? So the answer is absolutely yes. It's going to be the same for managed and native. Yes?
Have the engine been changed so that it will work on 64-bit yet?
64-bit. So the question is, has the engine changed so that it supports 64-bit? So our primary support is 32-bit, but it also works for 64-bit. In the VS, right? In 2010, yes, it will work.
So I think your question is, does it work better for 64-bit?
It doesn't work. It didn't work.
It didn't work. Yeah.
Yeah. Well, we didn't support 64-bit in early version.
That's right.
But in the next version, yes, we will. Yes?
Question about you talking about the feature of support native mode. Like if I mix mode, I mix the native core and the managed core. That's all these features will work.
Sorry, I didn't quite understand. Oh.
I have my project has some module is native, but some module is managed. We mix together.
Okay.
And with all these features, like you say, with this in native code, will work for mixed.
So if I can get the question is, can you, if you have different projects, or some different modules, some are managed, some are native, will it work? The answer is yes. It knows which compiler to call. It knows which one to use. Are you asking about CLI?
Yeah.
So it does run through the CLI as well, right? The warnings and things are different there, obviously. But it does digest CLI code.
Okay. Yeah, just kind of the screenshot. You like it?
Yeah.
Thank you. Thanks.
We can always take it away.
No.
We've done it before.
All right, let's move on to the second part, which is architecture tools. We're getting to C++ developers.
Ironically, the biggest code bases in existence are in C++, and we didn't have architect tools for those. I'm just pointing out the irony of that.
Now we have it. Let's use the same app for this purpose. So this application, I'm new to this, and now I wanted to understand what architecture is. So if I switch to here, so this solution actually has two separate projects. Ignore the modeling one. So we have a for the browser project and a Bing library. Now I want to understand what's in there, right? From here, I can see two projects. That's it. So if we wanted to get an up-to-date architecture diagram, where can you get it? The answer is in VS, because we can generate the architecture diagram right from your source code. So it's always up to date. All you need to do is go here. We have this architecture menu, and say generate dependency graph. We'll change the name, but for native it means by binary. That's a bug we'll fix. So let's start with that. So once you click on that, it's going to build your whole solution and analyze the binaries, and finally gives us a nice graphical view of the whole architecture. So in this case, we got two binaries, which are the blue boxes. One is the Bing library, and this one is for the browser XE. And what also tells me is this XE has a dependency on this library, which is pretty obvious. And then both of them have some dependencies on external components. So that way I get a first look at the overview of the architecture. The next step, I wanted to drill into each of these components. I can expand a node by just clicking on it. Now our tool is going to find out what's in there and then give us back a new view. So here you will see it actually shows us all these namespaces within this binary, and also the dependency relationships. Of course, you can drill into the components further by looking into what are the types in this namespace, and even what are the methods in the types. So here you'll see, now all these boxes are types, and I expand this particular one so that you can see the methods in this type. Now I can do some interesting things here. Like I can click on one of the nodes and say, okay, I want to see who is using this method, right? Now once I click on it, it shows me two arrows. If I zoom a little bit, it shows me one of the call is from a type within this namespace, and another call is from outside of this binary. So it shows us not only the relationships within the binary, but also cross binaries. Right? The other thing we wanted to do that's interesting to do is to maybe lay out a little bit, lay out the nodes a little bit. Sometimes you want to move things around. So this is pretty cool. Look at this. I click on this node. I want to move it around. See? It actually pushes other nodes away as I move it. And also, when I push the line, it becomes a curve. It pushes away. Okay? It goes onto the other side. So it's pretty smart. Now this way, you can move things around pretty easy. You don't need to do a layout or something like that. So that's pretty cool. And yes, you have a question?
Does this work for free functions that aren't inside?
You mean the layout, or the?
In other words, all these functions are part of the animation form.
Correct.
Or if you're just calling free function, it's not
So the question is if this works for a function that's not in a class. I believe it does.
Yeah, so we still post, even though you don't think that is, even free functions are collected together in a no-name space
Right.
class. So it still fakes it looks like that anyway.
Yeah. So the other thing you might want to do is, okay, now I get some good view of the architecture. Now I wanted to get to the source code. So maybe I wanted to see what this getValues method actually does. So I wanted to navigate to my source code. It's pretty easy from here. You can just right-click and say View Content. It's going to take me to this source code and scroll down to where the method is. So this way you can navigate back and forth. All right, so that's the dependency diagram by binary. Another dependency diagram that's very interesting and unique to C++, I'm going to show you now, is if I scroll up. Now on the top, you'll see that this particular CPP file includes several header files, which is pretty common and also unique to C++. What if I can get a view of how these header files are dependent on each other? Because oftentimes I'm lost in here, all these pound include sentences. Now you got this architect tool can help us generate a diagram like that. So all I need to do, right-click on this file and say, generate graph of include files. When I do that, our tool is going to analyze all these pound include information in there and give us a view of all these header files, including information.
It doesn't optimize it for you, though.
Right. That's the actual word, not optimized word. So this is the file I start with. This is the CPP file. And it shows me all these header files I'm including, and also shows which files these header files include. So all the way to down here. Now, there are some other things you can do on these kind of diagrams. Yes, you have questions?
So the question is, does it take into account pragma 1s? And the answer is yes. Because it actually, what it does is It actually looks at your source file. It looks at the binaries and figures out what actually got included.
Now, some interesting things you can do here. Let's say there's a particular header file I'm going to take another look at, or I think it may have some issues. I want to highlight that in my diagram. So maybe I want to use a different color for this particular node. Let's say this one. And if you right-click, you can categorize the nodes like you can do with email in Outlook. So I can mark this as category 1 and mark it red. And for a different node, I can do a different color. So this way I can highlight the parts I want. So another quite common user scenario is you will want to generate this kind of diagrams for your documentations. Does that happen often? So
should it happen often?
in an agile world, yes. So it's pretty easy for you to do so from here. So you can right-click on the diagram, and we have this copy image command, or you can save it as XPS. Either way. So let me try copy image. Or actually, let me bring up the legend and then copy it. Copy image, and I can paste it, or in a Word document or a PowerPoint. I just have to paste it. So it comes with all the legend as well, and with your highlighted colors. So you can start from here, document whatever you want.
I can see you sending it to somebody and saying, and send it to your team, saying, "Do you see how this guy structured his include files?"
All right, so that's the dependency diagram. Yes, you got a question. So the question is, are these color information surfaced to other files or anywhere else? Well, the thing is, all this information is in an XML file, right? So ideally, you could abstract this information by extending, by writing a tool to read that information.
Are you asking if it's persisted? Or are you asking, is it?
Can be used somewhere else.
Oh, I see. So can you do like classes, and can you mark like classes and methods and things as colors as opposed to just include files?
I can, but I don't think that's the question.
We're having a communication problem up here. What?
Okay. So.
We just added more questions here.
And then we answer ourselves.
Yeah, so.
Okay, so I can color the classes as well, of course.
So, then the question becomes, is there anywhere else within Visual Studio that I'm going to surface what this category is that I set? Or whatever I set on. So that's where you're saying it's persistent. But I guess the question is there anywhere else in your tool set? I realize I can pull it out of the persistent data.
Okay.
Is there anywhere else in your tool set?
I think I understand. So the answer really is no,
Right.
because these are generated on the fly. You can save them, but they're generated on the fly. So we can't keep the information. Like if you wanted to go back, if you have a CPP file and it's highlighted red, that's kind of the thing. Can you use it in other parts of Visual Studio, right? And the answer to that is no, because these are generated dynamically. Yeah.
So then the next question is, since I can pull this information out of here, can I right-click on that thing that says category 1 and give my own label?
You can add your own label.
Yes.
Yes. You can define the colors.
No, you have to use category 1 for. I'm just kidding with you. I know him, so it's okay. Okay. Good questions, though. So the question is can you do it backwards, where you say which source files use this particular header file, like we did with the who calls this one method, right? I don't think you can.
I mean,
if you pick a header file, can you
I
ask
see.
it which
other direction?
which CPP files use it?
Probably not.
We'll get back to you.
Right, we need to confirm that.
Same question, like, depending is, does it work with batch level? Which files are using this batch? Or which other batches are using this batch?
So if you look here, so these are actually classes. And it shows this class is using this class. Is that what you're asking? Okay, yeah, it does. Yes?
When it's analyzing a project and it's looking at the classes, will it extend beyond that? In other words, during the runtime, it starts bringing over DLLs, it starts looking over DLLs.
So do you mean the external DLs?
Yes. So it is in static sense, but if you look, but it does understand the concept of DLLs. So if you look at the diagrams, you can see that a DLL the next will depend on a DLL that you load dynamically. Now it won't tell you which one because that's when you're doing the running, right? But it at least tells you which ones depend on which thing. So if you say this actually has dependency on this DLL, or maybe I got backwards. It actually shows that, but it's done at a static level. It's not done dynamically.
Yes.
He's asking if you plan on using UML diagrams for this. Show the arc.
Right, understand. So the question is if we plan to use UML diagrams for displaying all this information, right? The answer is right now, no. So this particular diagram, is designed for showing the dependency relationships. We do have a set of UML diagrams in the box that you can use, but they are not the same. Okay. Yes?
He's asking, can you add more things to the tooltip that comes up
On the diagram, right?
Yeah, so like we have a comment about the classes, what the class is supposed to do.
Right. I don't think it does right now, but I have to double check.
we need
Okay. Actually, I haven't shown you the layer diagram yet. Almost forgot. So one thing that Cameron actually mentioned yesterday is a tool that we designed for you to help you to enforce your design into implementation. So you got a architectural design, very beautiful, you love it, but how do you make sure all the implementations are compliant with your design? So we got this, just really quick show you this tool in here so that you can, you're aware of this. So by the way, we do have all these UML diagrams in the box, and that's available in 2010. And additional to that, we have a layer diagram, and we're going to create one. Layer diagram is where you can design the layers of your architecture. So in the toolbox, you can just do it by creating box and lines if you wanted to start from scratch. And the other way you can do it is, for example, I have existing application. I can start from here, Solution Explorer. I just drag and drop onto the diagram. And it's going to create a box, represents a layer. And actually underlying it's connected, it's linked back to my actual project and represents everything in this project. So I can drag and drop another one. And also it's linked. So at this stage, let's just say, assume that this is my architecture design. I don't want this photo browser have any dependency on this Bing library. Okay? Now at this stage, I can do two things with this diagram. One is, this is my design, and it's linked to my project. So I can ask a tool to validate the architecture. So validate my source code against my diagram and see if there's any dependency relationship between these two components, then that's considered a validation to my architectural design. So that's one way you can use it. The other way is, let's say I made some changes to my project, but I'm not quite sure if that's compliant with the design. So you can ask a tool to say, all right, generate dependencies on the diagram from my source code. So if in my source code, actually there is a call from this photo browser to Bing library, the tool will generate a line between these two boxes. So you know, oh, okay, that's maybe some call I made there actually will break the design. And the other thing I just want to quickly mention is we actually have this part of the feature integrated. You can integrate that with TFS. So you can have it as part of your build steps. So say, okay, your program builds fine, but it's not compliant with my design. So sorry, cannot check in. All right, so let's switch back. Right, so just a few screenshots. I believe you will all get the slide deck. So, Architecture Explorer. Somebody was mentioning this. I didn't show you, but actually works for C++ as well. Layer diagram. All right, so move on to unit testing. Yay, we got a native unit testing framework. All right, let me actually use another app for demoing unit testing because it's simpler. So you can see how to write unit tests. This is MFC application that does a calculator, just the normal calculator thing. Right? So I go back to solution. Now calculator is the UI part, the MFC part of the solution. And calculator service is which we call a business logic layer that does the actual calculation. And if I open the calculator service.cpp file here, which I opened on the right side, it does actually the add, sub, divide, all these things, right? So pretty straightforward application. Now let's say I wanted to write a few tests to test each of these functionalities that runs real quick, that runs every time I make a change, and I make sure I didn't break anything. So the easiest way to do so is you can use the CPP unit test framework that we built in the VNext of VS. So all you need to do is here, add a new project, and you will find a new CPP unit test project template. So just to save some time, I created one here. It's actually blank. I didn't do anything. And if we open the source code, the template actually creates this unit test1.cpp as a default file. So this is where your test source code is going to go. So it doesn't actually do much, but it has include the right CPP unit test header file. That's part of our test framework. And it has using namespace, so you can start to write your test case right away. It's got a new test class that created for you, and within that, we got a new test method. So that's basically all the template does. Okay, let's start with include the calculus service header file. That's actually in this service project, and I wanted to use this method there. Okay, I'm including this. Now I'm ready to start writing my first unit test. I'm going to start by renaming this test method. So this particular test case is going to test add functionality here. Now I wanted to define a few things for my test case. So I want to define a calculus service so I can use it in my test case. And also I wanted to define a few variables. Pretty straightforward. Oops. Okay, I have got two values, A and B, and I'm starting to do my calculation. It says expected value is going to be A plus B, right? And the actual value, I'm going to use the calculus service to do the work. Okay, add, and then passing A and B. Right? So the last step I need to do here is to compare these two values and see if they're equal. If they're equal, then my test case would pass. Now I wanted to use assert features here. So it's actually part of our test framework. So I need to include, oops, sorry, not this one. CPP unit test assert.h. These functions are defined here. So I'm including this header file. And back here, I can then use assert. And in the IntelliSense, you'll see these are all the methods we support. And in this case, I'm going to just use equal and passing expected and the actual. OK, that's all I need to do. Now I'm going to build the solution. Once I finish building, I'm going to show you how you can find your test case, run your test case, and see the results. Looks like it succeeds. All right, good. Now on the left side, this is actually a new UI that we're building. Unit Test Explorer. And this window, once I build the solution, this window is going to discover all the test cases in my solution and list here. In this case, I just got one. Add test. I select it and right-click and say run this test. Now, of course, if you have multiple test cases, it's going to list all of them, and you can run them at once. OK, it's done. 7 million seconds. Pretty fast, huh? All right, so that's our first unit test. Now let's do something else to this test case. Now, there are oftentimes you want to decorate your test case with some attributes. Let's say who owns this test case or the priority of this test case. So you can do that by decorating this way. Now, this actually shows this attribute applies to this particular test. And I can define test owner and test priority this way. And there's another attribute I want to introduce you, which is called test ignore. Sometimes we need to temporarily disable some test cases for whatever reason. Now, this way, you can attribute this test case and say, OK, test runner, do not run this one. Ignore it. So if I build again and try to run it, right? So it actually shows it's skipped. This case doesn't get run. OK. Now let's start to write a second test case, which is, let's take a look at the source code here. So we just did one, which is add. That's pretty straightforward. But in this case, if we look at divide, it has some interesting things that we know if we divide by 0, it's going to throw exception. So how do we test that there is an exception in this term? Now go back to here. The test method divide exception test. Okay. Now, first thing I need to do is to define these again. But I don't want to do that because that's not very efficient. That's not how you want to do it. Oftentimes, you want to do a test method initialization method and clean up maybe at the end. So I can do that. First of all, let me define all these things at the class level. And then I want to move this initialization part into a test initialize method. And we do have that support in our test framework. So you need to say test method initialize and give it a name. Oops. And paste it here. So each of these test cases, before it runs, it's going to initialize these values. So I don't have to define it again. All right, now go back to this second test case. For this particular case, it's interesting because we wanted to try out if divided by 0 through an exception. So I have to redefine this value. But for other test cases, you don't have to. So I want to assert if there's an exception in this term. Now, we do have this method here that says expect exception. Now, if I take a look at what it takes, it actually takes in a functor. So before I can do that, let me define a functor. Right? All it does is it tries to divide A by B, which is 0. Okay, now we can go back and say you take in a functor. And also, we wanted to specify what kind of exception it's going to be. So in this case, it's calculate service divide by 0 exception. Okay. Now I can build, and our test window is going to discover the second test case. Right, it's here. I can run it, and it should pass. All right, so it does. Now we know it did through an exception. All right, that's the unit test part. Okay, I'll hold questions if you have any. Let me finish the last one first. Right, unit testing. You can write CPP native unit tests right out of the box and being able to manage and run the test case. Right, first part, last part, code coverage. All right, let's switch back. Now we got some test cases, and we're wondering how much code are being covered by these test cases. Now, oftentimes you want to do a code coverage run. Now, if you have used code coverage in the previous version of VS, you know the first thing you need to do is what? Instrument the binary, right? You need to pick what are the binaries I want to instrument before you run the test cases to collect code coverage data. Now, actually, in this VNext, you don't have to do so. To get code coverage data, can be as easy as just one button click. So if we go back to this window, notice there's a button here. Despite how ugly it looks, that's what we do in earlier builds so that everyone hates it so much, so it will be replaced when we ship. So this button that says Analyze Code Coverage. All you need to do is to click this button. Now this button, despite how it looks, is powerful. It's going to run all your test cases, and discover what are the binaries the test cases load, and dynamically instrument all the binaries. Get the code coverage data, and send back to VS on the UI so you can see the data. So just to save some time, I'm going to show you this one. Exact same app. I got a few more test cases added here so that it covers better in source code. So if I look at the unit test class, it got a few more test cases to cover sub, divide, all these functionalities. Now I did click this button, and it ran all these test cases. And meanwhile, send me back the code coverage data in this window. This is actually the window we had before. But now you don't have to worry about any instrumentation anymore. Now here shows, this is actually the binary that we are testing. And this is our test binary. It shows up as well. And these are the classes in there. If we expand here, these are the methods, right? Add, divide, multiply. And it shows you how much how many blocks are covered or not covered. So if I double click, let's say divide. And it's going to show us, I don't know if you can see that clearly, but all this code that's being covered by a test case are highlighted in blue, light blue color. So these are all covered. If I switch to this particular file, you will see that the code that's not covered is in red. And sometimes there are partial coverage as well. There's a possibility for partial coverage. It's going to be shown in yellow. So you can tell which ones are covered, which ones are not. And if you wanted to increase your code coverage, all you need to do is go back to the test case and add some more test case and do that magic button again. You can get the latest code coverage data. OK, so that pretty much wraps up all the demos. I do have a screenshot here. And that's our summary.
Thanks, Ron. Appreciate that.
Thank you.
So the big summary is we do think there's a pretty good set of ALM features for C++ even today. It seems that not that way because you see things that don't work. But there are some good things that you can be using today. Several of the existing ones exist in C++ and vNext. And there's a lot of new ALM features in vNext, right, for C++ going forward. So the bottom punchline of that is C++ developer teams have a much richer experience than ever before in how to develop their code. Some resources. Some of the architect tools are downloadable already in what we call the visualization modeling feature pack. And I've given the URL for that. Some of these have already happened. There is another C++ talk that Kate Gregory is going to give on Thursday, so I expect to see all of you there at 8:30 again. So you're used to the time zone, so you should be good by then. At the product booth, Kate's also there too, but Rong and I and Diego will all be at the product booth, so if you have some questions, further questions, you can always come by and see us. And we have a very good team blog that we're pretty active with, and we answer questions on that, so be sure to check that out, including a Channel 9 recently that over this topic, although it's much more watered down. You got the bigger picture on that. Going to skip some of this and get down to the evaluation. So I'm going to fill mine out. I did very well. So before you give me a really bad evaluation, you should consider about the features that you have that you like and whether I'll take them away. It would be helpful if you feel that there's not enough C++ content at TechEd. How many of you feel that way? Put that in your evaluation form, and how good looking the speaker is, and the other guy too. That'd be really good. So, but I really appreciate if you do fill out the eval form, not just because you might win something. That'd be really cool too, because we love to have the feedback. We'd love to hear what your comments are about the session and what we're going forward, and that's fine. So I really appreciate if you do that. And we have 40 seconds left.